Okay, so today we are going to talk about graphing linear inequalities with two variables. So here's a reminder slide. Let's talk about what information we know about this. We know that this has one variable, and the variable x, and it's telling me that x is less than -3. So think back in your head to all the wonderful things that you know about inequalities. We're going to graph this on a number line. I see that it has less than and -3, so I'm thinking, is this an open circle or is it a closed circle? Less than means I'm not including the number, so it's going to be less than -3, and I draw my line. So this is the graph of x is less than -3. So we're going to take all the information we know about inequalities, and we're going to use that when we talk about two variable inequalities. So here are some steps. You need to write these steps down in your journal. This will be something we will be checking for tomorrow. So write these steps down in your journal. Determine the slope of the line. So y'all know that's what my M is. Determine the y-intercept of the line. That's what my B is. Determine if the line is dashed or solid. So you know how we had an open and closed circle for one variable inequalities? So now we're going to have a dashed line. That's for less than and greater than, and we're going to have a solid line. That's for less than and equal to or greater than and equal to. Test a point not on the line, so you're going to want to test a point to see if it works. If it does, then that is a solution, and that determines where we shade. Okay? How about an example? That will make sure you have all of this written down in your journal and then move on to the example. Y is less than 2x plus 3. I'm going to determine what my M is. I look up here and I realize that my M is 2. I'm going to find what my B is. My B is 3. What type of line do I have? Do I have a dashed line or do I have a solid line? Well, right here it tells me that dashed is for less than or greater than. So my line is dashed. And where do I shade? Above or below? Well, it's telling me that it's less than, so I'm going to have to shade below. Now, we'll have to check that in a little bit to see if it's right. So I'm going to go ahead and graph. I'm going to go to my B, which is 3, and I'm going to use my slope, which is +2, rise 2, run 1, rise -2, run -1. All right, so now I've got my line, and I know that my line here, I've told myself that it is dashed, so I'm going to make a dashed line across these points. So I have sorry, it's not straight, human and all that. So I have a dashed line, and I'm going to shade below. Let's check, though, to make sure that I really am going to shade below. Let's pick a point, any point out here below the line. I'm going to pick -1 or 1, -1, 1, -1, and I'm going to plug this x and y value into my inequality to see if it proves true. My y is -1 is less than 2 times 1 plus 3. -1 is less than 2 plus 3. -1 is less than 5. Yes. So I know I'm shading below the line. So let me make this, let me make this really big. And this is what a solution to a two-variable inequality graph looks like.
So would an ordered pair on my line be a solution?
Well, no, because if I'm talking about this being less than or not less than or equal to, then anything on the line cannot be a solution.
Okay, so just everything below the line.
Everything below the line, not on the line, because we're talking about less than, not less than or equal to.
Okay, perfect.
All right, here's Ms. Sokolowski.
Okay, so this one, the only difference here is that we have an equation that's in standard form. So first thing I need to do is get my equation that's in standard form into slope-intercept form. So you guys can go ahead and do that yourself. I'm going to always write my x term first. My negative 4x. Thank you very much. Negative 4x right there. Negative 4x plus 6. Now I need to divide each side by negative 2 to get y alone. Well, what did I just do? I just divided by a negative. Do you remember what happens when we divide by a negative when we're using inequalities? We have to flip, exactly. We have to flip that inequality symbol. So now my equation is going to say, or my inequality, y is less than or equal to. Now I'm going to figure out what this is. Negative 4x divided by negative 2 gives me positive 2x. 6 divided by negative 2 gives me minus 3. So cannot forget that that rule still applies when we're dealing with two variable inequalities as opposed to one variable that we did a while back. So I have my equation here, my inequality. Now I can plug in these four lines. My my slope is 2. My y-intercept is negative 3. My line, is it going to be solid or dashed? This is where I look to determine that. And I see that it is equal to, less than or equal to, which tells me I'm going to use a solid line because all of my ordered pairs on the line are going to be solutions. And I'm going to shade below because I know that less than or equal to is always below the line. But I'm going to use a test point to make sure of that. So now I'm going to start at my y-intercept, negative 3. Then I'm going to rise 2 and run 1. So I'm plotting my ordered pair. I'm going to fall 2 and run to the left. Now I'm going to draw a solid line here. There is that. Very beautiful. And now I'm going to test a point just to make sure. So I'm going to test this point right here. I can test any point I want. Negative 2, 2. So my x is negative 2. I can plug it either into my slope-intercept equation or my original inequality. I'm going to just plug it in the original. 4 times negative 2 minus 2 times my y, which is 2, and I want to see if that's greater than or equal to 6. 4 times negative 2 gives me negative 8 minus 4. Is that greater than or equal to 6? No. Negative 12 is not greater than or equal to 6. That tells me that this point is not included. No. Which would tell me if I'm not going to shade above the line, then that means I'm going to shade below the line. So I'm going to shade all of these ordered pairs representing the solution to my inequality. Keep in mind everything on the line is also included. Now, if I have this second part to the question, which asks me if this ordered pair 2, negative 3 is a solution, I have two options. I can either look in the graph of what I just graphed and find the ordered pair 2, negative 3, and I would see that it is right here, 2, negative 3. That is in my shaded area, so that is a solution. Or I could do the same thing I did with this test point and plug it in my given inequality and test to see if I get a true or false statement. Okay, next one. I'm going to write an inequality for the given graph. So I need to determine my m, my b. I'm going to go ahead and write in what kind of line it was, where they shaded, and that will help me get to my inequality. So I see first that my y-intercept, I'm going to locate that first, is right here. My y-intercept is at negative 3. Now from there, what was the slope they used? I see that they went up 1 and over 2. Up 1, over 2. So they had a slope, that line has a slope of 1/2. The line is dashed and they shaded above. So what does this all mean? Dashed lines are either less than or greater than, no equal to. Above always means greater than or equal to. So if I can't be equal to, I know my inequality symbol that I'm going to use must be greater than. So now I write an inequality in the form of y equals mx plus b. I have y is greater than my m, my slope, which is 1/2, x, my b, minus 3. So this is the inequality that goes with the given graph. And the last one, number 4. Write and graph an inequality for this word problem. Theo's mom gave him at most $150 to buy clothes. The pants cost $30 each, that's important, and the shirts cost $15 each. How many of each can he buy? So we're going to write an inequality, 2 variables to determine this. I'm going to say that P represents my pants and S represents my shirts. And I know that it is, the pants cost $30 each, so $30 for a pair of pants plus $15 for a shirt. And how much do I have to spend? I have at most $150, so I know I have less than or equal to $150 to spend. Now I need to get this equation in what looks like slope-intercept form so that I could graph it, which means I need to get one of my variables alone. I'm going to get the P alone. I'm going to pretend like my P is my Y and solve it just like we normally would. So I'm going to divide each side by 30 here. So I get P is less than or equal to negative 1/2 plus 5. S, negative 1/2 S, thank you. So my slope is negative 1/2. My y-intercept is 5. Is the line going to be solid or dashed? Solid because it's equal to, and am I going to shade above or below? Below because it's less than. So now I'm going to graph this, go down 1 and right 2. I'm going to draw a solid line, and I'm going to shade everything below. So now you ask, well, what good did that do for my problem? I know that my x is equivalent to the s, right? The s is in the place of what usually is an x. So in an ordered pair xy, using my letters, pants and shirts, the s is what usually is x, and the p here is what usually is my y. So this is p. So any ordered pair, SP, that is in the shaded region would be how many shirts and pants I can buy. Now, can I buy a negative number of shirts? Is that possible? No. Can I buy a negative number of pants? No. So nothing in this region right here is really going to be part of my solution. None of that would be included. None of this would be included either because that's negative number. Can't have negative number of items. Can't have negative number of items here in this quadrant either. It just doesn't make sense related to the problem, which tells me that really the only solutions to this problem are those that are in this region right here, this triangular, or not really a triangle, kind of. In this region right here, these are my solutions that make this problem true. For example, let's see this ordered pair right there. I could buy 1 shirt and 2 pants. I could buy 2 shirts and 0 pants. I could buy 4 shirts and 2 pants. Any of these whole number solutions would work because we can't buy fractions of pants or shirts. So these are the different possibilities, or anything on my line here. Those would also be solutions. So that is the answer to that problem. Make sure you have all of these examples written down, and I will see you tomorrow.